Welcome guys to my next video about tools. Today I'll explain to you not only what does amp hour rating mean, but also many other even more important aspects and facts about power tool batteries or AKUPACKs that you don't know and should know before buying. My video is divided to chapters you see in the upper area. If you are absolutely sure you understand the topic, you can skip it so you only have to watch things that are unclear to you. This may be rather unusual, but believe me, I have monetization disabled, so I have no real purpose to force you watch entire video. You are here for info and you will get it. First chapter, Basic Electric Units, volts, amperes, watts, amp hours and maximum amperes. What are they? If you work with your tool, you want power, you want watts. The more watts does your tool consume, the faster it gets the work done. Electric power in watts equals voltage times current. So if you want power, you need both voltage and current. These three units are for both tool and battery. Then comes capacity in amp hours and maximum current in amperes. These are parameters of your battery. Capacity in amp hours tells us how long can we suck current from battery. In practice, more amp hours means more work done per one charge. Maximum current is written in amperes and unfortunately it is not presented on batteries. And it should be. Power equals voltage times current, remember? So, if your battery has bigger maximum current, your tool will be provided with more power and you will therefore do the job faster. Second chapter, differences between cells. Your battery is made of lithium cells, BMS and case. But main topic in this chapter is lithium-ion cell, because they are the thing that matters most. Today we use 18650 lithium cells. They are quite durable and not that prone to explosions like lithium polymer. Lithium cell has 3 volts when at 0% of charge, 3.7 volts at 50% of charge, and 4.2 volts at 100% of charge. Nominal voltage is half, so 3.7. Lithium cells are made in a range of capacities from 1.5 up to 3.5 amp hours. In tools, we use 1.5 up to 3.0 amp hour cells. Why? Because of next parameter, maximum sustainable current the cell can give. Cells can be made for lower power consumption or higher power consumption. Cells for low power are found in notebooks or flashlights. They usually stay between 5 to 10 amperes of maximum current. Lower maximum amperes allow for lower price. But we need high power cells. They begin at 15 amperes and end at 35. But why don't we see power cells above 3 amp hours? Because if you push the capacity to limits of our technology, there is no space for implementation of high power capabilities. The battery simply wouldn't survive it. With today's technology, best amperes are usually given from cells with 2 to 3 amp hours. It actually peaks at 2.6 amp hours. That's the sweet spot, where you get maximum current with nice capacity. Most common cell is Samsung 25R. It is commonly found in 2.5 and 5.0 amp hour packs. It is cheap, durable and quite powerful cell. Having capacity of 2.5 amp hours, it can give 20 amperes long term. Its stronger brother, Samsung 25S, can provide not 20, but 25 amperes. Samsung 20S has 2 amp hours and can provide 30 amperes. And top of the line is Sony VTC5A and VTC6. VTC5A has 2.6 amp hours, but it gives awesome 35 amperes. VTC6 has 3 amp hours and gives 30 amperes. So these have nice capacity with unbeatable current. Third chapter, differences between AKUPACKs. As you know, your battery is made of lithium cells, BMS and case. Case may be soft or hard. Soft case has rubber finish and it is prone to scratch and penetration, but it does not slip on angled surface. Hard case is sometimes more fragile and prone to cracks. BMS, or battery management system, is board that takes care of your cells. You need to take care of balance, overcharge protection, over-discharge protection, overheat protection, and overcurrent protection. Every brand has it different. For example, most brands have over-discharge protection in machine, but Hecht has it in battery. Some brands, like Parkside, have overcurrent protection, or fuse, in battery, while, for example, Makita has it in tool. Let's just quick look at what to look for in case you needed it. This cell layout is typical for middle power range of tools. They have 5 cells in series. First, second, third, fourth and fifth. And mostly 1 or 2 cells in parallel. AKUPACKs with this layout are often called 18 or 20 volt. It is the category of tools with 13 mm drill or 125 mm angle grinder. So, how do we figure out parameters of these packs? Voltage of the pack is sum of all cells voltage in series, because series connection adds voltage. In our case, 1, 2, 3, 4, 5 times 3.7 is 18.5. For maybe aesthetic purposes, these 5S or 5 series packs are usually called 18 or 20 volt. But what about power? Of course you remember how to determine power. Power equals voltage times current. So connecting cells in series gives us greater voltage. But there is more. We can even increase current and capacity. If you connect cells in parallel, you sum their capacities and currents. They split the current in half every twins. Fourth chapter, choosing AKUPACK. Let's assume that one blue cell has 2 amp hours and gives 20 amperes. Then this AKUPACK has approximately 18 volts depending on charge and gives 20 amperes max and only runs as long as 2 amp hours go. 18 volts times 20 amperes is 360 watts. That's like ideal for cheaper and weaker drill, but sometimes we want our tool to run longer and with more power, more strength. So we buy this. 18 volts remain since we have the 5 series cells. But 2 parallel rows tell us we can get 40 amperes and work longer with 4 amp hour capacity. Maximum power delivered to tool is 18 times 40, and that's 720 watts. That's completely enough for more powerful brushless drill with capability to drill like 16 mm holes into steel. Or it can be also quite enough for hungry angle grinder with 10,000 RPM and with huge powerful brushless motor. But this angle grinder's potential goes beyond capabilities of these batteries. So then I need to go for batteries with better cells. Then I choose my 6 amp hour battery made of VTC6 cells. It can give 60 amperes, so my angle grinder would get 1000 watts. That's powerful, just like Cordit one. To sum it up, manufacturers have divided their tools in categories. Some tools are powered with 12-volt batteries, so-called, that have 3 cells in series. Most tools are made for 5 series. And you even can choose different AKUPACKs. They may have 1 or 2 parallel lows and can have cells with different capacities and different currents. Having one family of tools that share the same battery type is a must. You really don't want to have every tool for different battery. You just bring your tools and batteries on worksite and supply batteries to those tools that are used most today. You also need to plan. You need to buy batteries strong enough to cover power requirements of your tools. As I said before, usually 2.0 to 3.0 amp-hour cells are most powerful. So if you buy these fat blocks of 2 parallel cells, you need to look for 4, 5 and 6 amp-hour batteries. 5 amp-hour batteries usually give a little more power, while 6 amp-hour batteries give a little more runtime. And how many of them should I have? To cover your all-day work, there is no time to be running between charges just to finish your last screw. You need to work. Then, when battery runs out, change it. Once work is done or work time is over, you can charge all your batteries. The only difference is when there is room for charging, like in garage, you can then have less batteries. While you work with one, another one is charging, and then you swap them. 5th chapter, prolonged lifetime. If you have huge army of batteries, you also need to take care of them so they last. Tools require some maintenance. From time to time, you should clean them. Sometimes you could change gear lubricant or brushes, and that's all. Batteries don't require maintenance, but they require good conditions. Good conditions include temperature. If you work hard and your battery gets hot, leave it cool down before charging. Charging hot battery significantly lowers its life. If you plan to work in heavy winter, you should keep your batteries in warmth of home or car as long as possible before putting them to your tool. Cold or even frozen battery won't be able to give you nominal current and capacity. For example, if your battery has minus 10 degrees centigrade, its current can be even halved, so your tool has half the power. Moreover, usable capacity drops to 60 or 70%. Another thing that affects battery life is voltage. It is best to store your battery at exactly half charge, that's 18.5 volts, for 5S batteries. So, if you just put your tools on shelf for entire winter, best practice is to have them half charged. Storing them fully charged damages them over time just slightly, but it lets you do some work when it comes out of nowhere and there is no time for charging. The worst you can do is storing battery discharged, or even continuing using it when it drips last drops of juice. This damages electrodes inside and slowly destroys cells. And last thing that influences battery life is charging current. Many manufacturers offer different chargers. Faster charger with more power and more current of course charges your battery more quickly, but the faster you charge it, the more significant wear you cause. For best lifetime, charge your battery in weakest charger. Generally speaking, anything above 2 hours is absolutely okay. 6th chapter, off-brand batteries. Actually, there is nothing wrong with them, but generally they are rather bad. But why? Let's just forget about Wish and eBay scammers for a while and talk serious manufacturers. I'll give you an example. Tool manufacturer sells his AKUPACK for $200. Off-brand manufacturer finds out that the price is too high, so he tries to manufacture almost exactly the same AKUPACK. He is then able to sell it for $160. The pack has same capacity and same nominal current, But when you go to store and have to choose between original and off-brand, you say that $40 difference ain't that much and go for original. The off-brand manufacturer figures it out, so he needs to lower the price. He does it by using B quality cells instead of A quality. This lowers the price to, let's say, 120, but B quality cells sometimes have little lower capacity. Their maximum current is also sometimes not up to nominal, but few percent less. You can also cheap out on spot welding, using thinner nickel-plated steel strips instead of thick, pure nickel ones. The battery is then a lot cheaper and finally, it's selling. But quality issues cause it to die sooner, or even catch fire more frequently than A quality. To make it more optimistic, you can even buy off-brand battery that's better than original. For example, I have made this pack myself. Parkside only makes 2 or 4 amp-hour batteries with not that strong cells. They give like 15 amperes max. I used Sony VTC6 that can give 30 amperes and also their capacity is 3 amp-hours per cell. For results, I performed test. I started cutting steel profile. Compared to original, the cutting speed was 60% faster. I also made some huge modifications that allowed me to measure current draw. The current peaked at 63 amperes. That's a little over 1 kilowatt. So power-hungry tool is definitely glad for more current. Final chapter. I hope that everything is clear for you now, that you understood everything. Now you know that generally 5 amp-hour AKUPACKs give most power, usually more than 4 or 6 amp-hour packs. You also know how to treat your battery so it lasts more years. If there is something you wanted to know or you would like to see a video about, write it down in the comments. Goodbye.